Okay, so I've made some nice little breakthroughs tonight. I've managed to put some turtles on top of my little model that I've simplified, um, and basically I've got them to run away from the tsunami when they sense it, and they run to the safe spot, which is good. Which is kind of what we want. It doesn't take into account any elevation, so they don't go uphill. They just simply see the tsunami and then run away from it. So yeah, I've got it set up. So if I just run it quickly, you have an idea. Tsunami goes, and then they run towards it. And you saw at the beginning, those three turtles ran off straight away because they saw the small bit of blue. That's just kind of, I guess, a bug that we're going to have to work out. You can see once this guy saw the tsunami, he ran towards the safe spot, and they're safe, which is cool. The tsunami does go really slowly for some reason, but that's something we can work out another time. And I've put on these two sliders, one for population. So you can see now we've got a lot more turtles, and the other one is speed, so that represents how fast they can travel once they see the tsunami. So if we set that up, we'll probably see a lot more of them dying because they won't be able to get away from the tsunami, or not. They just seem to be getting away. Because I've set the tsunami to go off after 30 ticks. Just, I don't know why, just to provide some random. Okay, yeah, cool. So you see these guys are dying, and when the patches are blue, then the turtle dies. Cool, so that's them traveling really slow. So remember, we've got the population variable and the speed variable. I'll just show you the code quickly. This is mostly written myself. I've taken some from an example on Complexity Explorer, taken from the ants, if anyone did that. So I talked about this in my last video, setting the environment here. So I've given the turtles a variable which is tsunami seen. So so basically it's a 1 or 0. 0 representing they haven't seen it, and 1 representing they have. So when they go, we ask the turtles to check tsunami, which is a check in the patches of a radius of 10 around them, if the colour is blue or not. So that's sort of actually them sensing whether there's a tsunami or not. And if it's false, if there is no tsunami, they carry on their normal maneuvers, which is move turtles. But if they do have blue in there, it means they can see a tsunami. So then they change their tsunami seen variable to 1. So basically, on each tick, each turtle checks for a tsunami, and if the tsunami seen variable equals 0, the turtles move around as normal, so they move around randomly. And if the tsunami seen variable is 1, because they've got blue patches within 10 pixels of them, firstly they change their colour to red so that we can see it, and they move to the safe spot. So if we quickly just talk about move turtles, this is like their normal activity. So they're randomly moving around either left or right and moving forwards 0.5. So that's them moving around as normal. Once they sense the tsunami, so they face the safe spot and then move forward by the speed variable, which we set earlier. And that's it, really. So we've managed to get them to sense their surroundings in an area of 10 around them, and if there is a tsunami, they run to the safe spot as they know where that is, and if not, they kind of just go about their normal lives. I think the next step, which I might borrow from the Complexity Explorer Advanced AMP module, is so if the turtles can sense other people panicking and running, so that might indicate that they need to run as well. But I don't know, I reckon this is good progress so far. Unfortunately, it's not applied to any sort of like GIS data, but I think that's pretty cool. We just run it one more time, set it up. So you see those guys straight away here ran away from the blue dot, and then after 30 ticks, coming up now, the tsunami goes, and then they run to the safe spot. I think that's pretty cool. There we go.